Welcome back to the next session of electrostatic potential and capacitance. Friends, till now we studied about the potential due to a dipole and its uses, and the electrostatics of conductors, potential energy in presence of electric field and in absence of electric field, and the dielectrics. What is the necessary, what is the use of studying the dielectrics? Suddenly I introduced a new topic called as dielectrics. Why I introduced? You will understand in these videos. Let us start one by one what we have studied till now, including chapter 1. Just take a bird view of this. Once you understand this concept, this is very fundamental. Once you understand this, hardly a 30 minutes sentence or 30 seconds explanation. So you will understand the chapter 1 and 2 in very easy way. So let us start one by one. In the first chapter, we say there is a charge called as source charge. It will produce the electric field around it. That means if there is a charge, there is a electric field. So now in the first chapter we died about only these two things: charge, its experience or its force on the other charge. Charge due to, if there is only single charge, then what it produces? Then it produces the electric field. So electric force and electric charge and electric field, three things we studied. That means in brief way, if there is a charge, there is a electric field. Come to chapter number 2. So if there is a charge, there is an electric field. If there is an electric field, then if I bring another charge, say from the infinity to the point next to this electric field vector A, then there is a potential. That means I can say there is a charge, there is an electric field. There is an electric field, there is a potential if I bring a charge from infinity to the point against to the direction of this electric field. Next, I am going to introduce one more thing. So if there is a Q, there is a E, there is a E, there is a V, there is a V, then what next? That I am going to deal today. So to understand in this concept in a broader way, let us discuss step by step method. So now, in the previous discussion, let us see here what I mean exactly. Look at this. If there is a charge, there is a potential. And right now I am neglecting the word E. There is a charge, there is a potential. Then what I will do in the next process is, now to this charge, I am going to add little bit of charge in terms of installments. Say small dq. If I add small dq to this source charge, obviously what happens? The strength of the electric field increases. Once the strength of the electric field increases, then what happens to the potential? Obviously, potential also increases. Then add little more of charge to the source charge. Once again in terms of small installments. Then again the strength of the charge is increased. Once the strength of the charge increases, at the same time the strength of the electric field also increases. Once the strength of the electric field increases, obviously the strength of the potential also increases. So then again if I add little more of charge in terms of installment, small charge, dq means very small amount of charge. Again if I add to the source charge, then again the potential increases. Every time potential is increasing. So with this we can conclude that, right, if the charge on a conductor increases or if the charge increases, potential also increases. Hence I can write here directly proportional. That means Q is directly proportional to the potential. Once this is, if you understood this concept, our next job is to relieve or release or remove this proportionality by a constant. Question is, if charge increases, potential also increases. But the question is, at what rate increases? That I have to calculate. Is it increases by 2 times, 3 times, 4 times? constant value that I have to calculate. That means if charge increases, potential also increases. Then if I want to remove this by equal sign, then I must use a constant. Then I have to write here Q is equal to C into V. What is C? This C is called as proportionality constant. It's called as proportionality constant and is called the rating capacitance of the conductor. Capacitance of conductor, or also called as COC, or is denoted by capital C. Please note of the symbol capital C, not small c. Then one thing we understood here: if Q increases, then V increases. If Q equal to CV, then C is the proportionality constant, and C is called as a proportionality constant, and E is called capacitance of the conductor. Then, if I rearrange this equation, Q equal to CV, it is one more very fundamental equation which we have studied in the present year. So now we understood Q equal to CV. If I rearrange this equation, then what happens? If I rearrange the equation, then it becomes C is equal to Q by V. That is the ratio. What it is? The capacitance of conductor is the ratio of. Alright? It is the ratio of. What is this? This is charge. This is what? Charge. What is this? This is potential. Then we have to define what is COC. That means capacitance of a conductor. So now, if I write the definition goes like this. Capacitance of conductor is the ratio of what? Charge divided by potential. What we have done to the charge? We have given the charge to this charge Q. Then after giving the charge, what happened? Potential is increases. Potential increases means rise in potential, increase in potential. That we have to write. So then capacitance of a conductor is the ratio of charge given to the conductor to raise, to increase, to enhance. You can use any word. To raise its, after giving the charge, what happens? Potential increase. To raise its potential. So for 1 mark, it's very important definition. Define capacitance of a conductor. So if we define the capacitance of a conductor, definition goes like this. Capacitance of a conductor is defined as it is the ratio of charge given to the conductor to raise its potential. Right, one thing. Or one more thing is that, what that? Suppose if this charge is, I don't know how much charge it is, so I don't know. I will rewrite this equation. C is equal to Q by V. Right, Q by V. Suppose if V is equal to 1 volt. If V is equal to 1 volt, then C is equal to what? Q. How much charge I have to give? Q amount of charge is given to the conductor to raise its potential by how many volt? 1 volt. Because the SI of the potential is volt. So now charge given to the conductor to raise its potential by 1 volt, then that is called as what? Capacitance of a conductor. One more definition I can write here. Or capacitance of a conductor is defined as capacitance of a conductor is, look at this, C is equal to Q. That only I have to use here. Capacitance of a conductor is equal to charge. What I did here? Given. Charge given to the conductor. After giving the charge to the conductor, what happens? Potential increases. How much it increases? 1 volt to the conductor to raise, to increase, to enhance its potential to raise its potential by how much? By 1 volt. By 1 volt. You can, instead of using 1 volt, you can use unit. Take potential by a unit. So these are the two definitions of COC, or the capacitance of a conductor. In the examination, they may ask define capacitance of a conductor. So in order to, you can write any one definition. So now, after defining this, let's go to some more important topics of this meeting. That is capacitance of a conductor. Then, SI unit and symbol. The SI unit of capacitance of a capacitor is farad. Small f, farad, and symbol is capital F. So now we have to define the capacitance of a capacitor is 1 farad using this equation. C is equal to Q by V. So now how to define 1 farad? So now I will write here. I am writing the definition of 1 farad. How to define this one? So just erase this part. So anyway, we have a fundamental equation here. C is equal to Q by V. So in this Q by V itself, let us substitute some standard values. That is, if Q is equal to 1 coulomb, the SI unit of charge is coulomb, and it is 1 coulomb, and V is equal to 1 volt, then obviously what happens? C is equal to 1 farad. How to define this? Very simple. The capacitance of a conductor is said to be 1 farad, or the capacitance of conductor is said to be 1 farad, or is called as 1 farad when 1 coulomb of charge is given to the conductor. I repeat, 1 coulomb of charge is given to the conductor to raise its potential by 1 volt. That definition I have to write. So now, if capacitance of a conductor is said to be 1 farad, capacitance of a conductor is said to be 1 farad, is said to be 1 farad when 1 coulomb of, don't write symbols, you have to use the word, 1 coulomb of charge, 1 coulomb of charge given to the conductor, 1 coulomb of charge given to the conductor to raise its potential by, how many volts? Only 1 volt. By 1, to raise its potential by 1 volt. So this is the definition of 1 farad. So the capacitance of a conductor is always measured in terms of farad. That is, it is named after the scientist Michael Faraday. Then here I wrote the capacitance of a conductor. Then is this capacitance of a conductor is depending on anything? Exactly. It is depending on 3 important quantities. What are those quantities? So it is also asked in the examination for 3 marks. The capacitance of a conductor depends on the capacitance of a conductor depends on. So 3 important things we should keep in our mind. So it's asked in the examination, 3 things are there, and also asked for 3 marks. One is size and shape of the conductor. Size and shape of the conductor. So size and shape is a common language. So if I remove this one, if I use the physics word, then it becomes a dimension. So it is depending on the dimension. That is size and shape of the conductor. And if I write the second point, it is depending on the dielectric media surrounding by the conductor. That is dielectric media, dielectric medium surrounded by the conductor, surrounded by the conductor. So what is the meaning of this? In the previous video, we discussed about the non-linear and linear dielectrics, that is polar and non-polar dielectrics. In that, I give some example: hydrogen chloride or hydrochloric acid, nitrogen, oxygen, carbon dioxide, carbon monoxide, and oxygen molecule. These are some examples of the both polar as well as non-polar dielectrics. In that, suppose if I place a conductor in the air, then it becomes oxygen. In that, the conductor is surrounded by water, air. Dielectric media is water, air. At that time, capacitance is 1 value. That is, say some farad, say X farad. Suppose if the same conductor is dipped in hydrogen chloride, at that time conductor is surrounded by the hydrogen chloride or hydrochloric acid dielectric media. At that time its capacitance increases. How it increases that electron afterwards, but actually it is increases. That means it is also depending on the dielectric media surrounded by the conductor. And the third point is presence of another conductor. Presence of other conductor nearby. Presence of other conductor nearby. This is one more important point on which the capacitance of a conductor depends on. What is the meaning of this presence of other conductor nearby? That means if one conductor I have placed in one media, so already it's showing some capacitance of the conductor. So in this, if I keep another conductor nearby it, then the capacitance of this conductor affects to this one. As a result, its capacitance varies. That means its capacitance also depending on this conductor if it is nearby. If it is far away, no need to worry. But if it is near, then again it depends. As a result, we must say that the presence of other conductor nearby also affects the capacitance of the conductor. These 3 points are meant for 3 marks. I repeat once again, very very important. The capacitance of the conductor depends on. Mention the factors on which the capacitance of the capacitor depends on. In the examination, they will ask for 3 marks. Question number 19 or else 20, part C. So size and shape of the conductor, dielectric media surrounded by the conductor, and presence of the other conductor nearby. These are some important topics on the COC. Then those who are planning to appear C, for them I am giving some extra important number, that is int. So the value of the earth is calculated, the capacitance of the earth is calculated using the formula C is equal to 4 pi epsilon naught K into R. We know already 4 is constant, pi is also constant, epsilon absolute permittivity of the value is also constant, K dielectric media, air, that is for air, is 1, and R radius of the earth, that is 6,400 kilometers. So if I substitute, it becomes 711 microfarad is the capacitance of the earth. Is the capacitance of the earth. Capacitance of earth. Look at this. 711 microfarad is the capacitance of the earth. That means C is directly proportional to the radii. So if you substitute, then you will get the value 711 microfarad. Since this value is very very big value, so we adapted some more value to measure. So that is number 1 microfarad. Farad is a very very big value, so that is why we adapted one more value, that is 1 microfarad. That is 1 mu f, is mu. Second one is 1 nanofarad. 1 nanofarad. That is 1 small n capital F. The third one is 1 picofarad. P-I-C-O-F-A-R-A-D. 1 picofarad. This is 1 small p capital F. 1 picofarad. So this is our experimental value. 1 picofarad is the experimental value. So now, since as I said, microfarad is given very big value, so we have adopted these two values, that is nanofarad and picofarad. So the symbol of picofarad is 1 p It's very clear to you people. Then, after studying this one, let's go to the one more important topic that is called as capacitor. So, based on this, the capacitance of a conductor, they have developed a device called as capacitor, on which the charging of a device or any electronic device will be done using that capacitor. It is called as capacitor. Then let me explain that. The next heading is capacitor. So now, before understanding the shape of the capacitor and everything, so what have to write by looking at the diagram of the capacitor, how to write the definition? Very simple. Look at this. The capacitor is consisting of two conductors of same area. Look at this. See, they must have same area. Area must be same. So now this is A, this is B. They must separate it by a small distance. In that small distance, there must be a dielectric media. Now you understood why we studied dielectric. So these two capacitors must be separated by a small distance. In this small distance, there must be what? A dielectric media. So area must be same. So at least it looks like not look like same. So in this media, so in this area, so we are placing what? A dielectric media. That's called as insulator. So better we say called as insulator. So now, what is a capacitor? Capacitor is a system of two conductors separated by an insulator. That is the definition I have to write. So capacitor is a system of two conductors. Capacitor is a system of two conductors. Separated by an insulator or a dielectric insulator. Separated by an insulator or a dielectric. Now, in the present case, I have considered two plates here, A and B. A and B are the two conductors. They are separated by a small distance. What? Small distance D. And in that small distance, we placed an dielectric insulator or a dielectric. And one thing, after this, the plate A must be charged with so it is acquiring only the positive charge, and the plate B must have the negative charge. So that means what? One plate is associated with the acquiring positive surface charge density. The plate B is acquiring negative surface charge density. As we know that if the electric field is there, the source charge is positive, always the electric field lines are radially outward. Property of electric field lines. So that is, there is a positive charge, there is a negative charge. Hence, the electric field always moves from positive plate to negative plate. That means between these two plates there is an electric field. In that zone, electric field is there, insulator is there, or dielectric is there. So now this is what the explanation of capacitor. After this, again as we studied in the previous section, that is Q is directly proportional to V. If I replace this, it becomes Q equal to CV. Then if I write this, it becomes Q by V. Again, what is capacitance of a capacitor? There we define capacitance of a conductor. Now we are defining capacitance of a capacitor. Capacitance of a capacitor is the charge given to the conductor to raise its potential. So that we write the definition. Capacitance of a capacitor. Capacitance of a capacitor is the charge, or you can write ratio also, the charge given to the conductor, to raise its potential, raise its potential. So this is one thing. Then symbolic representations of this. This is what the diagrammatic representation. Then if you want to study in any electronic circuits, then how to represent these capacitors. Let us start step by step. Right. Then right. Unit symbol. Then the SI unit of capacitor is again farad. Farad. Symbol is capital F. Right. Then representation. How to represent the capacitor? There are two ways to represent the capacitor. One is constant value, constant, and another one is variable capacitance. Constant capacitance, constant capacitance, another one is variable capacitance. Two things are there. Then look at this. While drawing this, care must be taken. For that, look at this. One line. Second line should be parallel to it. Should be parallel of same length. Then draw two legs. At the head, you write just C. This is the capacitor. Length must be same. I repeat once again. The length of the conductor should be same, not in a irregular manner. Height should be same. This is what a constant capacitance. If it is variable, then how to draw this one? Same capacitor only with two legs. Then draw this. Then put a C mark here. That is showing the C. Then draw an arrow mark here. This arrow mark says that the capacitance of the value is variable. That means you can set it according to your value. The next one is, as I said, between these two between these two conductors, there is electric field. The maximum electric field that electric medium can withstand. That means without breaking. So that means if I draw the capacitance here, two fields here like this. So now here is what is there here? There is there, K is there. K means so here dielectric constant, E means electric field. It is the maximum value or maximum electric field which that even the electric field withstand without any breaking. That is called as dielectric strength. I repeat, it is what it called as? It is called as dielectric strength. It is called as what? Dielectric strength. So with this, I am completing the topic capacitance of the conductor and the capacitor. In the next class, we will study the parallel plate capacitor, which is very important for the examination point of view. Thank you.